You might have learned about this man in school. His name is Democritus, and he was a Greek philosopher who lived thousands of years ago. The reason why I'm bringing him up to you guys is that Democritus theorized the existence of a particle that everything is made up of. He thought of it like this: you can take any object and divide it. Every time you divide it, it got that degree of division smaller. So, if you were to keep on dividing, it would get smaller and smaller and smaller. But he thought that this couldn't go on forever. I mean, there had to be a limit. He thought that matter, at its most basic unit, couldn't be divided further, and that at this stage of division, everything is made up of the same thing. He called this particle atomos, which means indivisible in Greek. Fast forward to 2,500 years later, and we had many breakthroughs with the atom. We learned of the strong nuclear force that keeps the protons and neutrons together, and the electromagnetic force that keeps the electrons bonded to the nucleus. However, we also learned that we can break these forces, and in turn release a lot of energy. Therefore, in a way, the word that we use for this particle is wrong. Rather, Democritus thought of a particle that we now call the fundamental particle. A fundamental particle, unlike the atom, is not made of any other particle. If you were to get one step more basic than this, it would be just pure energy. A lot of people might think that this means they are made of energy, but that is not true. Rather, they are a burst of energy, or excitation in a quantum field, which is an invisible energy field that fills the entire universe. Each different quantum particle has different quantum fields. Think of it like a ripple in a pool of water after it is disturbed. However, because of the way they're formed, they're not really particles. They're halfway between a particle and a wave. To put it simply, when put into complete isolation, the ripple is mathematically expressed through the wave function and begins to behave like a wave. The wave function is complex valued, which means that the information it carries is constantly fluctuating in superposition. Now, superposition is a state of existing and not existing at the same time. I know, it's confusing. This means that, while not interacted with by any other particle, the fundamental particles are waves. However, when interacted with, the entire wave function collapses. This means that fundamental particles are no longer waves and now exhibit the properties of a regular particle. So, if, say, an electron hits this particle, its information is no longer fluctuating and it only gives off one piece of information at one time. But why does the wave function collapse? The answer is we have no idea. But we can utilize this property to power quantum computing, where we exploit the wave superposition to store and process more information using qubits.